Hey everyone, welcome back to the channel, and in this video we are learning about types of languages. This is important in order to understand, when we'll be doing like data structures, algorithms, and even though we'll be doing it in Java, you have to, have a basic idea about what all these things are and what type of languages you are working with, be that Java, Python, or C++. So without further ado, let's just jump right into it. Computers like internally, like at the very minute details, is just bunch of zeros and ones, okay, binary numbers, and we'll look more into like how binary numbers are actually stored in memory and whatever, how we convert normal decimals to binaries and all these other things, the memory management, all of these things will be covered in the future lectures. Speaking of programming languages, what are programming languages? Programming languages allow us to, we have some idea and we write that in form of a code and we get the output for that, like whatever you want to do. Let's say you want to, create a function, or let's say not, if you are not aware of functions, let's say you want to create a program, okay, that takes input of all the students in your class, okay, or let's say you want to create a program that gives you the table of 2, or you want to create a program that just, gives you a nice message like hi, how are you, and good morning, and all these things. So we can do that via like programming languages. And programming languages basically, as I mentioned earlier, like internally at the very minute details, it's just a bunch of zeros and ones. So when you're executing these instructions, like you're instructing your computer, hey computer, please do this thing for me, or tell me the time, or hey computer, please this is a program that I have for you, like please print the date for today. So these are basically just instructions that your CPU is giving, like you're giving to your computers. And computers contains all these things, like there's a CPU, there's a RAM, and how all these things work, we'll look into later on. So internally, if it's just zeros and ones and instructions that you're giving to your computer, it would be very difficult to write all these instructions in just zeros and ones. Okay, that is the reason we have like programming languages that allows us to write all of these programs, like, okay, computer, do this, take this, output this, perform this, calculate this, and do all these things. That is the reason we have programming languages, so that we can write it in a human readable format. Internally, computer is going to translate it in a bunch of zeros and ones. Your computer's problem, not my problem. Okay, cool. Let's look at the type of languages that we may have. You might have heard about so many languages: Java, C, C++, Python, and so many other languages. The first one we are going to look into is called procedural language. Now, procedural language, like very initial, years of programming, as you can see on the screen, it specifies a series of well-structured steps and procedures to compose a program. Now we can do this in, it contains like an order of statements, functions, and commands to complete a task. So for example, it can be like, hey, first you have to input a number, then you have to input the second number, then you have to add the sum of that, and then you have to print that. You can also, you can see this flow of structure that is going. Is it at any point of time going to be input a number, take the sum of the two numbers, then input the second number? It will not happen like that, right? You definitely need two numbers and then only you will do the sum. So you can see the series of steps that are happening. This can happen in many ways. It can be loops. If you don't know what loops are, don't worry. You can do this like in your statements, cases, functions, so many other commands. Basically, the idea is to complete a task like that. Now you might be wondering, hey Kunal, so many languages do this. I am personally, let's say you might be like, hey, I don't, let's say, know that much about all the languages, but I'm pretty sure many languages do this. And you are correct. You are correct. Java does this. Python does this. C++ does this. So can we say like Java, C++, and Python and all these other languages, they follow the procedural language, the properties of this? Most definitely, they do. All right. Now let's look at the next language. Next type of language is the functional language. Functional language, what is it? So writing a program only in pure functions. If you don't know what functions are, do not worry. We have a separate module for that later in the course. Functions are basically, in simple language, whenever I say this thing, right? Whenever I say in simple language during the course, that basically means understand what it's doing Ignore how it's doing it because it will be covered later in the course. If you want to Google yourself, you can do that. For now, just ignore how it's doing it because that is a separate module in the course. Functions is basically you bundle a code together in a particular, let's say something, and you can use that and reuse that many times. If someone asks you, hey Kunal, you have 10 files, 10 programming files or whatever, and in every file you have to, take two numbers in, sum them and print the sum. Does it make sense that I write this program again and again for 10 files? I can just write this program in one file and use that particular program in every other file. Saves me time. Also will help me in changing the particular function, the particular program. If there's an error in the program, I can just change the main one. Automatically all the ones will be changed rather than changing in every single file. Functions allow us in doing that. So pure functions are basically never modify the variables. Again, if you're not aware of variables, do not worry. Variable is simply if I'm saying a is equal to 10. So a is a variable and the value of that is 10. Name is equal to Kunal. Name is a variable, value is Kunal. We'll look into it later on in this particular, like shortly only in the next videos. So it is never going to modify it, but only create new ones as an output. Or in other cases, like in simple terms, if I want to share with you what functional programming languages are, then it can be like used in situations where we have to perform lots of different operations on the same set of data, because it's not modifying the original data, it's creating new one as an output. If you're like, hey, I am doing machine learning, here's the data set that I have for you. I'm like, okay, cool. This is my data set. Let's play with this data set and, create some nice algorithms and machine learning models and whatever, right? So we are doing these things with this data set, and I am like actually utilizing that data set, for various operations. And it might be the case that I'm not modifying the original file. It might be the case that I'm taking a copy of that data, manipulating it, changing its type or whatever that I'm doing. Another example I can give you is they also follow first class functions. Now what are first class functions? Very simple, do not worry. This is very simple stuff. First class function I'll explain to you right now. Functions are basically just, block of code that I can reuse again and again. Many simple things you can do in programming languages like a is equal to 10, name is equal to Kunal, a is equal to b, let's say a is equal to, let's say number variable. Number, I'll just write it down over here. Let me just write it down. So if I'm saying, let's say in simple programming language term, I'm saying a is equal to 10, then I say b is equal to 30, and then I say c is equal to b. So can you see that I reassigned c to b? If I print c now, if I try to get the value of c, it's going to be equal to what? The value of b, which is 30. So the value of c is also value of b, 30. Do not worry about this. We'll cover this later on. But the important thing to note over here is, can you see how I'm reassigning variables like this, c to b and things like that? This is basically means that if you are able to do such things with functions as well, reassigning function variable name to other function, doing all these other things, that basically means that is like first class functions. An example for this language that follows these sorts of, properties can be Python. Python follows such properties. Python has first class functions. May not be purely functional, but it does follow the functional programming theories. Now you might be asking, hey Kunal, you're saying Python is procedural also, saying it follows functionals also. Which one is it? Wait a minute. Let's look at object oriented. What is object oriented programming? So again, do not worry if you did not get the gist of it. Just a basic understanding is fine. Do not worry if you did not get the details, because we have a functions section separate as a module. And variables, what are variables? We will cover that in the next videos. In this video only, I believe. Object-oriented programming. It basically revolves around objects. Now, what is object? The idea is that code, the code file, the code that we have, plus the data, if you combine these two together, it forms an object. What do I mean by an object? Let's say you are like, hey Kunal, can you please collect us a data for me of 10 people that contains the roll numbers of those people. Okay, that's a problem statement. What is the type of this data going to be? Forget programming. What is the type of roll number going to be in simple terms? Integer. Integer. Let's say, hey Kunal, create a collection of data that contains names of all the students. What is the type of this data going to be? String, alphabets, letters? You're like, hey, Kunal, create a collection of data that contains all the addresses of people. What is the type of this going to be? Maybe like it's going to be like a string or a paragraph, you know? What is the type of all the collections of all the people, the marks of all the people, the CGPA going to be? Decimal numbers? Some CGPA 9.5, 9.2, 9.1, 8.7, whatever. Now you might be asking another question. Hey, create a collection of data of all the students, where each student has, let's say, 3 properties: name, roll number, and marks. Now you get confused. Okay, what is the data type of this going to be now? What is the data of each student going to be of which type? Is it going to be string because we are containing names? Is it going to be the integer because we are storing the integer, like the roll number? Is it going to be decimal point because we are storing the marks? We are storing all of these different types of data types. So what is one single data type that can be of a student? It can be a custom data type, which we can specify using classes. Do not worry about what, if you don't know what classes are. Classes in simple terms is this only: named group of properties and functions. If someone is saying, hey Kunal, create a separate data type, like a type of data for student. You're like, okay, this is neither an integer, nor a string, or alphabets, nor a decimal, because it is collection of all. This collection of all is called a class. Okay, so and an instance of this class is called an object. So for example, I am of class human. We all are of class human, but I am an object of class human. I'm an instance of that class. A class is like a template, a property. We all know humans have a few properties: 2 eyes, 1 nose, 1 mouth, 2 ears, 2 hands, 2 legs. This is a property, a template. Using this template, God has created many objects. We are actually objects. We are actually the memory inside your RAM. You know, when you say A is equal to 10, A is actually the variable, 10 is actually the object. That is the thing that is actually in the memory. We'll talk more about that later, do not worry. But I hope you are able to understand the difference between classes and object. We'll cover that later on. Classes, object-oriented programming is a separate section. But in order to make you understand what object-oriented programming, is in type of languages, it's basically dividing our code into various chunks so that it makes it easy for us to develop, debug, reuse, and maintain the software. For example, if you want to create a function, or sorry, not a function, a program, computer program that has information about your car. It can have many information. What is the color? What is the type of the car, supercar, or what is the, how many engine does it has, or what is the type of the engine? Okay, so many things. Let's say in your program, now you want to change the type of the engine. You're saying, hey, I want to change it from diesel to petrol, or petrol to diesel, or from fuel to electrical. Does it really make sense to change the entire car? When you go to your car mechanic and you want to get the, some parts changed, do they change the entire car or just change that particular part? They change that particular part. If we divide the entire program also in these parts, engine has a separate code base, steering wheel has a separate code base, other properties have separate code bases. If you want to make a change in that entire program, just change that simple part of the program. That is what I mean by like object-oriented in simple terms. So I'm trying to explain it as simple as you can, as I can. Do not worry about how these things are working. Do not worry about it. Ignore it, because it will be covered later on in detail. Ignore what is happening. Just understand what these things are. Ignore how it's happening. Okay. Now, Java supports object-oriented principles. Okay, we can create objects and like classes and all these nice structures that I told you about, like entire student structure or whatever. Python also supports this. C++ also supports this. Now you might be asking, hey Kunal, you're saying Java supports both procedural and object-oriented. Python supports all the three. C++ also supports object-oriented and procedural. Are these languages all the types of languages? The correct answer is yes. Like a particular language, if it's object-oriented, it does not mean that it will not follow procedural, fundamentals, procedural rules or functional rules. Java, for example, follows object-oriented and procedural. C we have that follows procedural. C++ we have that follows like, procedural. We can also do like some functional programming that was as well. It also follows object-oriented programming. Python, follows procedural, functional, object oriented. So this idea that one particular language can only be of one type, that is not correct. Okay, that is not correct. It's like hybrid sort of like structure to follow many other theories, and that's basically about the types of languages. We are learning Java, so we'll be doing heavily focused on object-oriented principles. This is also very important for your interviews and stuff. Object-oriented we'll be doing very detail. Has so many properties, inheritance, polymorphism, abstraction, encapsulation, everything will be done in detail. Do not worry about it. That was a basic understanding of this thing. Let's move forward. Another types that you might encounter are known as static versus dynamic languages. Let's look into what is static and dynamic language. Let me create a, okay. So let me just write this thing over here so you're able to see. I think we all can see this now. Cool. Okay, this looks good. So speaking of static versus dynamic languages, this is based on, so that was based on like the previous 3 points that we had were like structure of the, how we write code and how things are structured and everything. What are static versus dynamic languages? Static languages, before moving forward to that, we gave the student example, right? So I can say I have something like name is equal to Kunal, something like this. Okay, now here you can see when I write name is equal to Kunal, the name, the type of this variable that we have over here is string, or like letters and alphabets, right? If I say something like roll number is equal to 56, this is of type integer. Okay, if I write something like marks is equal to 93.6, this is of type decimal or float. Now there are 2 ways to approach this problem. Like the problem is that how do we know which type, how does the programming language know what is the type of these variables? Okay, how does the programming language know that? So the basic idea over here is that there are 2 ways to do this. One is the static and one is the dynamic. What is static? Type checking is, performing the type checking. It does the type checking at compile time. So what do I mean by compile time? Remember when I mentioned that we write the program in programming languages and computer will, compile that and or interpret that in whatever sense and convert it into the machine readable format like zeros and ones or whatever, assembly or whatever, so that the computer can understand this. This conversion is known as compilation. Your source code, the code that you will be writing in Java or C++ or whatever, that gets converted to machine code that machine can read, and then machine will read that code. This is known as compilation of your program. So when you're writing a is equal to 10, for example, there are 2 ways to do this. When the compilation is done and when the program is running, that time, if the programming language is like, okay, this is integer, that is dynamic language. Entire program is run, it is being converted to machine language, and now programming language is like, okay, program is running, the value of a is equal to 10, so a is an integer. Program is running, the value of a is equal to Kunal, so value of name is equal to Kunal, sorry, name is equal to Kunal, so name has a type of, let's say, string or alphabets or letters or whatever. Okay, this is known as dynamic language, where you do not have to worry about specifying the type previously. So you don't have to tell the programming language like, hey, I am giving you a variable a which is of type integer, like int a is equal to 10. What is happening in this case? This is statically typed. Here, while the program is compiling, while it's converting your source code, the code you have written in machine code, during that conversion time, the programming language should know what is the type of a. During that time. So the type checking, here it is done at compile time, while the thing is compiling. So you can see this left hand side thing, what is happening is compile. Whatever happens here in the right hand side of the equal to is runtime. This is the actual thing that is stored in the object. This is the actual object that is stored in the memory. To understand more about this in detail, watch the next lecture. I'll cover it in detail. What are the memories and how the reference variables and everything is working in the next detail. For now, just imagine that this is a variable a It has a type that is equal to whatever type it's equal to, in simple case. Again, do not worry how it's working because that is coming in the next lecture. Okay, so in static type languages, if I'm saying you have an integer a, the value is equal to Kunal. Is this possible? Is this Kunal thing that I have on the right hand side is really an integer? No, it's a string, it's letters and characters. This will give me an error. Error. While my program will be compiling, it will be like, hey, you mentioned a is integer but you're giving string. Error. So errors will show at compile time. Okay, I hope the first point is clear. Type checking at runtime and in static, type checking at compile time. What is runtime? When the program is running after the compilation period. Okay, once the program has been converted into machine code and when that machine code is running, that's basically when the runtime thing is happening. Okay, very simple stuff. Okay, when you write a is equal to 10, okay, let's say this is dynamic language. I'm not specifying a is equal to 10. I'm like, when you run this program, you figure it out yourself. That is what I'm saying to the language. So in this case, it will be like, okay, when the program is running, so when first it will compile and then in the runtime, like it will allocate the memories and everything. 10 will actually be stored in some memory or RAM. A will be pointing to that. All these things. We'll look into it in the next lecture. But here, let's look at the second point now. So error will show at compile time. I already showed you. If I do something like, something like string a is equal to 10 or not a, something like I can do int a is equal to Kunal. Error. Kunal is not an integer and you are specifying it as integer. Error at compile time. Let's see how we can get an error in the dynamic languages. Let's say you do a is equal to 10. This will work perfectly fine. This will work perfectly fine, and here you may say that another possibility can be a is equal to, in the next line I can say of the code Kunal. First a was integer, now a is Kunal. Is it going to give an error? Pause this video and think to yourself. In dynamic languages where type is not specified beforehand, type is only calculated after the during the runtime. In Python, for example. Okay, if you said yes, then that's not correct. Actually, it will not give an error. Okay, why it will not give an error? Watch the next video. It's basically an object and references thing, and it's actually like first the value was 10 and then the value is going to point towards Kunal string, because at the compile time it does not really care about the type, so it can definitely change things like that. Okay, first a was pointing to 10, then a will be pointing to Kunal, then a will be pointing to 13.5, whatever now float or decimals you want. But this will give an error in static languages. Here I have specified a is equal to 10. There's a rule associated to it. In the next line, if I do a is equal to Kunal, this will give an error in static languages. Okay, so when it's compiling, it will be like, hey, you said a is equal to 10, which is an integer, but in the next line you are assigning it a string. This is an error. You can definitely do something like this. Okay, so that's like error will show at compile time. Error might not show till the program is run. So in this case, it can be something like if you do, if you're doing something like a plus 10. So you're adding a string and a number. This will give an error. Okay. We'll talk more about this later on. Now, declaring the data type before you use it, we already covered this. Int a is equal to 10, like a is type integer, value is 10. Declaring the data type before we actually use it. No need to declare the data type. Now, what are the advantages, disadvantages? More control. Okay, you have to write a little bit more code, but you have more control over the types data. Runtime errors are reduced. And in dynamic languages, no need to specify the type or anything, so just saves time in writing code, but it might give error at runtime. That was pretty much about it, and we'll cover more about the memory management and all these things in the next video. Now let's answer a few questions that you might be having, right? You might not know what are variables, you might not know how the objects are working internally, what all this memory thing that I'm talking about. So let's answer that. Let's take the very, very simple stuff, like the very simple stuff. If you write in a programming language something like a is equal to 10, as simple as it gets. I'm just writing a is equal to 10 over here. Let's dive deep into how this thing is working. So when you're talking about memory management, right? There are two types of memories here in your computer, programming languages. One is the stack memory, one is the heap memory. Okay, so this is the stack memory and this is the heap memory. And when you write in your programming language, when you write something like this, a is equal to 10, when you write something like this a is known as what? Reference variable. And this 10 is known as what? Object. A is not the object. Many people say A is the object. No, A is the reference variable, 10 is the object. How is this stored in memory then? Your variables and function calls and whatever, like for now, let's just say variables, they are stored in the stack, and the actual object that is in the memory, like the actual value of that object, that is stored in heap. In this memory, let's say in its RAM or whatever, and A is going to be pointing towards that object. So when you're saying, hey, give me the value of A, it's going to say it's 10. How? It's going to see A is here. What is A pointing towards? A is pointing to 10. This A is going to point to the address of this particular thing. You know, every object and stuff has an address in the memory, like some address in some RAM or whatever. Very nice. Computer science is very fascinating. In simple terms, this is how it works. So you have A is equal to 10. A is a variable in stack memory pointing towards the object in heap memory. The stack and heap and everything is just memory management, how they are done in like computer, like scientists and stuff. They have computer scientists, they have, you know, made these things, like there's a stack memory, heap memory. These things will be much more clear when we'll be doing like recursion and stuff. For now, this is as simple as it gets. It's not like a separate hardware piece in your PC. Okay, it's just how memory is managed. It's how memory is managed. So A is in the stack memory pointing towards the heap memory. Heap is, let's say, another section of your memory, your RAM or whatever hard disk, and there's a heap memory allocation over there in your, you know, sometimes there's also like some, if you talk about CPUs, they also have some memories, they have registers and stuff, but we don't have to go in too much detail. Simple terms, variables in stack memory pointing towards the object in heap memory, that is simple. But that is not what I'm trying to make you understand here. I'm trying to make you understand how these things are working and how this is going to help us. What is the actual meaning of object? What is the actual meaning of reference variable? Let's look into that. This is the best example and it will make things very, very clear. So now we are answering the very important question. The object and memory and reference variable, all these things. Previously, I mentioned that I am an object. By far, you should know that the reference variable is just like the variable and the actual value of that variable is in the object. I'll repeat it again. Variable does not, A is not the actual value of 10 in A is equal to 10. 10 is actually in the memory, in the heap memory. A is just pointing towards that. For example, I am Kunal. My object is my body. This is a physical object in the memory of this world. So this is the object Kunal. Object. When I'm saying name is equal to Kunal. Okay. So this object Kunal, this is object Kunal, actual object. I might ask you, hey, what is the type of this object Kunal? Human. We are all of class human. So objects have a type and we can define those via classes. We'll look more into that later on. So this is the object in the memory, in the heap memory. Okay, this is in the heap memory, the object. If you want to call this object, if you want to call myself, my physical self, how do you call me? You call me via my name. So you can say Kunal. This is the reference variable pointing to this object. So if Kunal is giving a party, okay, so you'll just say, hey Kunal, pay the bill. Kunal will pay the bill and this object's bill account will be reduced, like this object's money will be spent. Let's say my mom also calls me something. She does not call me Kunal. She calls me son. Son is also the same person. If you are calling me, you will call me Kunal. If my mom, let's say only my mom, if let's say my mom calls me Kunal, same person is being called. If my mom calls me son, same person is being called. If my sister calls me brother, same person is being called. So if Kunal is giving a party, or son is giving a party, or brother is giving a party, let's say in a hypothetical world, I might have a girlfriend, might call me baby. Or if baby is giving a party, money is being spent of the original object only, just one object. It's not like there are 4 Kunals for these 4 people. What am I trying to make you understand with this? If you write something like A is equal to 10, B is equal to 37.5 or whatever, you by now you know these are objects, these are reference variables, these are in heap memory, these are the actual objects, and these are in the stack memory that are just pointing towards these objects. What am I trying to make you understand with this example then? The thing I'm trying to make you understand is one object or more than one, this is what I'm trying to make you understand. Listen very carefully. More than one reference variables can point to the same object. Point number one. Point number two. If any one of these reference variables change the object, original object is going to be changed, and it is going to be changed for all. If son gets a haircut, then if son gets the haircut, then baby also gets the haircut, right? If my mom told me to get a haircut, it's not like my sister will not see that haircut. Even though the change was made via this reference variable, original object was changed. And since all of these other variables are also pointing towards the original object, the change is going to be visible to all these variables. This is how it sort of like functions in like Java and Python as well. So in the future, we will be looking into like some concepts like pass by reference, pass by value, you might have heard in C++. Java does not have this thing. It only has pass by objects value. Sorry, not objects value. Pass by reference value. Okay? It does not have like value or anything. Pass by reference value. It's there in Java only. We'll talk more about that later. Okay? How these things are internally working. But what it's doing, are you able to understand? If I'm saying there's a list, something like this, let's say simple Python example. Let's say I say A is equal to a list, which is like 1, 3, 5, 9 or whatever. And then I say B is equal to A. What is happening internally? This is happening internally. List is nothing but a collection of numbers or elements. You might have also heard it like in arrays or whatever. Okay, let's say this is array. Forget about programming language. Let's say this is an array in Java or Python. So actually internally, all of this is in stack memory pointing towards this, which is 1359. B is pointing to A, means whatever A is pointing to, B will also point to that. Very simple stuff. Now if you make a change via A, if you say the 0th element of whatever A is pointing to should be 99, this will be changed to 99. Very simple stuff. Now when you display output B, my question to you is B also going to show this updated 99 or is it going to show the original one? Pause for a minute and think about it. If you said that it will also update 99, that is true because the answer is in front of your eyes. B is also pointing to the same object. So if this simple terms, I repeat it again, if the object was changed via one reference variable, then this change will also be visible to all the other reference variables that are pointing to the same object. Okay, there are more things we'll consider. Mutability, immutability later on. But this is just like a simple example that I'm giving you. Okay. Don't worry, we'll cover mutability, like how we can modify and all these things, objects, and sometimes it may show, sometimes it may not show, but this is the theory I wanted to show you. I noticed you were not able to see, but I just wrote output B only. Okay, that's it. Output B was the only thing written. You did not miss out on anything. One more thing I want to share with you, it's another important thing, which is what happens when there is no reference variable to the object. Say, my name is Kunal. Reference variable to something, this is my body, okay, my object. Now someone calls me baby, same object. Let's say a third person came. Let's say, I don't know, this is a hypothetical situation, by the way, trying to make you understand. So, I can either be called Kunal or baby. So if you call me by Kunal or she calls me by a baby, same person is being called. Okay, let's say there comes another person and let's say this person's name is another object. So this name is Adam Levine or whatever. Adam Levine is married. Let's take some other example. Who is a popular celebrity who is not married? Or I can just take some random name. random name, okay, Alex or Alexander or something, okay. This new guy comes, and now let's say baby now points towards Alexander. Okay, let's say Kunal is not the baby anymore. Okay, so if Alexander is called, the same person will be called. Now baby will be called. All the changes made via baby variable will be in this object now. Okay, let's say Kunal now gets upset, like I'm not the baby anymore. Okay, so what happens to Kunal is that Kunal goes into the forests and like leaves the material world and everything and gives up his name. Okay, so now there is no more name Kunal even. There is no name of this person now. This person is living alone in the forest. Okay, so when this is an object, what is happening? This is an object with no reference variable. There is no reference variable to this object, meaning there is no variable that is pointing towards this object. So this will be removed from the memory when garbage collection hits. So in Java, there is something known as garbage collection. In very simple terms, what is garbage collection? Very simple terms. Garbage collection means that objects that do not have a reference variable pointing towards them, like this example, no one is pointing to this object. When the garbage collection hits, it hits automatically. Okay, when it feels like it needs to free the memory. In that case, all the objects that do not have a variable pointing to them, they will be removed from the memory, deleted. That happens automatically. We'll look more into that later on how we can, perform some functions when garbage collection is hit in object-oriented programming. We'll look into later on. There's a finalize on whatever. Okay, so if you're doing something like a is equal to 10, so this basically means a is pointing to an object 10. Then you say a is equal to 37. Now a will be pointing towards 37. Okay, what happens to this 10? No one is pointing to 10. Garbage collection will come and remove it. Yamraj, if you can get that reference. Okay, one last thing I wanted to share was in like previous example, I mentioned something regarding the dynamically typed languages. So why is this thing working? So if I say something in dynamic type language, that in Python, for example, if I say a is equal to 10, then I say a is equal to Kunal, this will not give an error in dynamic languages where the type is decided at runtime. How this is working internally? Now you might be knowing a is pointing towards 10, a is equal to Kunal. Now another object will be formed, Kunal. A will be now pointing to this. This will be removed when garbage collection hits. That's how Python works. Very simple stuff. That's the entire idea of objects and things, and we'll go more into details of this when we're learning about classes, object-oriented programming. But this is the general idea of memory management. Some simple data types we'll look into next lecture is like the integer and like character and like booleans. Very simple stuff like int a is equal to 10. Just created an integer a value 10. This is the object. This is a reference variable. This is in stack. This is in heap. This is pointing to this. That's it. If you say something like output the value of a, it will actually see where it's pointing and get that value and print us for us. If you say a plus b, what is equal to c is equal to a plus b, this will get the value from heap. This will get the value from heap. Combine it and add a value in another variable. This also will be in heap. All the objects are in heap. Nothing to think about here. Very simple stuff. All right. Thanks a lot for watching, and we will see you in the next video. Make sure you like, share, and subscribe, and check out the links in the description as well.